Hello everyone, welcome back to our channel. Let's discuss the next named reaction, that is Blum Aziridine synthesis. Let's see the statement. The reactants are oxirines are initially treated with sodium azide to form azido alcohol. The formed azido alcohol treated with triphenyl paspene to produce aziridine. Okay, so if you see, oxirane means what? It is a three-membered cyclic compound with oxygen atom. Oxirane, oxa. Next, aziridine means aza. Aza means NH. So oxygen is going to be replaced with nitrogen. Here oxygen valency is 2, but nitrogen valency is 3. That's why we need to place hydrogen. So conversion of oxirines to aziridines by treatment with sodium azide and triphenyl paspene is commonly called as Blum aziridine synthesis. Let's see the statement along with the equation. From the oxirines we are preparing aziridines. Okay, this is the general formula of oxirane. Initially we are treating with sodium azide. Here we are having Na plus ions and N3 minus ions. So the nucleophile is N3 minus. Here we are observing SN2 substitution reaction. So in SN2 reaction, what happens? The nucleophile always approaching from the back side. Okay, so here what is happening? The N3 is approaching from the back side, so this bond is going to be cleaved. O minus will be there, so followed by hydrolysis to produce that O minus with OH. Azido group is there, OH group is there. That's why it is azido alcohol. The formed azido alcohol treated with triphenyl paspene, thereby what we are observing? This oxygen is replacing with NH. Clear? But here we need to observe one thing. Here see the R groups. Here R groups are in the same side or not? Above the plane. But here also R groups are in the same plane, but the below the plane. Here above the plane is converted into below the plane. That you need to have in your mind. The second thing, if these two oxygen bonds are above the plane, then these two bonds will be below the plane. If these two bonds are below the plane, then these two bonds will be above the plane. That stereochemistry you need to understand. Okay, let's see the mechanism. So initially what is happening? SN2 reaction we are observing. Okay, nucleophilic substitution bimolecular mechanism. Here the nucleophile is N3 minus. So N3 minus is approaching this carbon. This CO bond is subjected to cleavage. Oxygen will take the negative charge, subjected to hydrolysis. Thereby we are converting that one into OH. This is azido alcohol. Now see the situation. In N3 we have 3 nitrogen atoms or not? We need to arrange 3 nitrogen atoms according to the valency or not? See this. N, N, N. See the first nitrogen. Here we have triple bond. Nitrogen valency is 3. That's why triple bond. If you see the middle nitrogen, what we are observing? 3 bonds plus 1 bond. 4 bonds or not? 4 bond means valency is more. That's why we have created a positive charge. Here if you observe this nitrogen atom, we have 2 bonds or not? But nitrogen valency 3, that's why we kept minus charge. Okay. Now what is happening? This azido alcohol treating with PPH3 or not? Triphenyl paspene phosphorus is having lone pair of electron, always wants to donate lone pair of electrons to the electron deficient center. Here see what happens. In order to form a bond with this azido alcohol, the phosphorus is donating its lone pairs to this nitrogen. Why? Because to neutralize the charge on the central nitrogen, these triple bonding electrons are moving towards the nitrogen. Thereby, positive charge is creating on the nitrogen or not. That's why phosphorus is donating its electron. Phosphorus donated electrons means phosphorus will take which charge? Positive charge. And forming nitrogen phosphorus bond. Okay. The triple bond converted into double bond and minus charge. Now see what is happening. This minus charge is forming a pi bond with this nitrogen. Thereby nitrogen valence is increasing so that these pi bonding electrons move towards this nitrogen. This nitrogen will take the minus charge or not. So nitrogen minus charge, phosphorus plus charge. This minus and this plus both will form a pi bond or not. See this pi bond formation. Here also we have formed the pi bond or not. This is also pi bond. This pi bond is converted into single bond. Am I clear? Now what is happening during the heating? Here this nitrogen is removed in the form of nitrogen gas. N triple bond N. Then we will come up with OH. This nitrogen directly attached to this carbon. N double bond PPH3. Now what is happening? In order to form the cyclic transition state or cyclic compound, what is happening? The oxygen losing its lone pair of electrons to the phosphorus. In order to maintain the valency of the phosphorus, these pi bonding electrons move towards the nitrogen. So the nitrogen will take minus charge or not? So nitrogen is taking minus charge. Here oxygen is taking positive charge and forming a bond with phosphorus. So here oxygen donated its electrons or not. That's why positive charge to neutralize the oxygen valency or the oxygen charge. What is happening? We are removing H in the form of H plus. The H plus will move towards the N minus. See this. Oxygen forming a phosphorus. The N minus takes the hydrogen, so NH bond formation takes place. Okay. Now what is happening? Oxygen donating its lone pair electrons to the phosphorus again. Then there is a formation of pi bond here. It means the phosphorus valency increased. So there is a cleavage of phosphorus nitrogen bond. Again nitrogen is taking minus charge or not? So NH minus. Oxygen donated its lone pair of electrons means oxygen will take a positive charge. Right? This is the species. The N minus is going to attack this carbon. Why? Because the oxygen is having positive charge means it wants negative charge or not. That's why this carbon oxygen bonding electrons move towards the oxygen. So here we are creating a positive charge or not. That minus is attacking this positive and forming your final compound. Okay. Let's see the applications. What we are observing here? Simply the oxygen should be replaced with NH. Oxygen replaced with NH. Okay. NaN3 and PH3. Okay. Already we know that oxygen replaced with what? NH. But as for the stereochemistry is concerned, if the two bonds are above the plane, in the product the bond should be below the plane. Simply. Okay. Next. Here see the situation. One bond is below the plane. So oxygen is replaced with NH. The below the plane line will be above the plane. Okay. Then here see. This is the situation. Oxygen replaced with what? Nitrogen. But here what is happening? One group is below the plane, one group is above the plane. So as far as stereochemistry is concerned, what happens? Whatever the group which is below the plane, that must be above the plane. So the CH3 must be above the plane. This group will be the below the plane. So here TR we are using. TRCl means trityl chloride. Triphenyl phosphine methane chloride. We can say. It's not triphenyl phosphine. Triphenyl methyl chloride. We can say. Okay. So this is all about your Blum Aziridine synthesis. The name itself indicates synthesis of aziridines, 3-membered cyclic compounds, by using the Blum Aziridine synthesis. Okay, thank you very much.